Saludos and welcome to another episode of the NHCFAE Career Series podcast. I'm Karen Perez, your host, and today we're highlighting one of the most critical areas of aviation, radar technology, and how it helps to keep our skies safe and efficient. Our guest today is Patricia Navarro, a radar technician with the FAA. Patricia, thank you for joining us. Can you share a bit about your role and what radar technology means in your daily work?
Pretty much I'm a radar tech at GSS, known as in the FAA. What we do, we fix the radar so we can provide a feed to air traffic so they can control the airspace. They always nickname us the eyes of the sky because without us, they will not be able to have the feed. Yes, they can have the radios, but they need the visual. It's an automation. Like people ask me, well, how did that describe to a normal person? Well, first of all, define a normal person, but the only way I can describe my system is when you're playing a game. You have to have that video to control air traffic. Yes, you have a lot of keys that play in place, but without the radar, they don't know the exact position of the plane.
Sounds like radar is an essential part of aviation. Can you walk us through how radar systems connect to air traffic operations?
Espérame. How does it connect to air traffic? We have 9 different radars. I specialize in 9 different radars, but I concentrate on 3. And I've been doing that my entire career since I joined the military all the way up into the FAA. So that's what helped me land the radar job. And I love it. If you can go back, will you change it? Absolutely not. The importance of my job to air traffic is I'm capable of, if you want to put it to normal terms, I'm taking apart an engine from a vehicle, putting it back together and making that car work. So the radar, the one I concentrate is the ASDE, which is inside the airport. And what this allows air traffic to control ground traffic. So, of course, it starts from the center, which controls 60 nautical miles and above. Then they transfer it to the TRACON, which controls between 20 nautical miles and 60 nautical miles. That's the airspace. But when that aircraft hits 20 nautical miles, it goes into the tower. So the tower brings that aircraft to be able to land them. So once they land in, my radar takes over because now they can see where they are in the airport and the taxiway, how they're going to get from landing to the gate and vice versa. So that's what I like radar, because it gives you this animation, and it gives you, back in the era when I first started in the military, it was just raw video, a little line. So air traffic had defined what that line was, and it's considered primary video. But in comparison of the secondary, now air traffic is able to see the little plane itself with how fast it's going, the altitude, the aircraft ID, and they have 60 characters of a message. So if they're having, for example, if one of the engines is not working, they can type it in the code. So air traffic knows we need to land this aircraft right away. So how does it play into the NAS? My system, any radar will go through STARS. And the STARS is a bigger automation, and a lot of people compare it to ERAM, which is the bigger system that translates anything that comes into analog digital information into data information. So it goes through FTI. A lot of people play a big role into my feed, right? Because without the communications, I won't be able to send the feed. So my radar spits the feed via FTI, goes into STARS. STARS grabs that information, converts digital analog information into a data presentation. We send it back through FTI into displays for air traffic to actually display it. So, and when you go into the tower, they have about I work in IAH. So they have 7 displays that are dedicated to the ASDE itself. And you have 7 more on top, which is STARS. They like to see what comes in and what's actually in the airport. And the beauty about the ASDE is that it allows air traffic to prevent any aircraft collision within the floor. It's also allowing them, whenever of course, we are humans, right? And humans make mistakes. So whenever a maintenance person, whether it's a tech or tech ops or airport or security, is crossing the runway and is going to interfere with the aircraft, it notifies them. So that's the beauty about the ASDE, because it's a live feed and it tells them to prevent the collision. Do we want to do that? No, but it's a nice feature because if a vehicle is crossing the runway, it's going to interfere with that aircraft landing. So now, not only you're going to destroy that vehicle, but you also, some of these aircrafts carry about 300 plus people. So I like my job because at the end of the day, I know that a lot of people made it home safe. That's how my job interacts with air traffic.
Yeah, and sounds like we have all these different systems talking to each other, and you're sort of a translator between
Pretty
all
much.
of them.
I'm the
So
map.
you're the map.
Yes, I'm your map. I'm your Google's map that
That's
allows you
very,
to go to point A to point B.
very nice. I think that's a pretty complex job. You have to be well versed and able to understand the language of each of these systems that happen to talk to the aircraft and the different systems on the aircraft. So I think that's pretty neat. What's new in radar technology? How has the field evolved and continue to evolve when it comes to automation and new technology integration?
Well, we continue getting educated, right? It's just like any kind of technology. Yes, you have the old timers that have a hard time adapting to new change, but I always compare my system to TVs. Back in the days, you had to get up, turn the knob to change the channels. Then we evolved to the digital ones where you have that remote. And now we have the flat screens where you can do a touch and voice command your TV to be turned on. That's how my radar is. It went from very ancient components, from analog, and it's kind of unique how to see the system going because it went from analog on a dial-up line to the T1s and not to the IP addresses. It goes from analog to digital, back to analog, back to digital, back to data. How am I preparing for this? I'm responsible for any kind of maintenance, any kind of modification into my system. And I like to be involved because if you're not involved with any modifications, you don't know what the change is for your system. And this is why I tell my senior techs, yes, you're used to doing this way, but at the same time, we have evolved. So there's things that we can do, make them better. Yes. The senior technicians have the theory when it comes down to analog. So that's why I like to pick their brain because they know stuff that I don't know. When it comes down to now all these data, IP addresses, because we can comply to each other, bouncing ideas and still learn from each other, plus learn from the books. And the worst case scenario is you also have T-staff, which is our secondary support, and then AJW. So we're getting prepared on a daily basis. It's not a lot of people will tell you, well, you have a lot of downtime on radar. No, you don't, because things are changing, technology is changing, even our internet is changing. So if you don't educate yourself, you're going to fall behind. So I like to prepare myself by reading my TIs, asking questions. Right now, I have the ASDE-X, which is not the newest version, is the previous before the new one, but I'm getting ready to get the ASDE-4, which is going to provide a more clear display, a crystal display on the systems. So there's a lot of stuff that is evolving, right? So by us doing this, by having a newer system, you can integrate with outside stockholders. So right now, I only have the capability on my system to share it with, I do believe I have 14 customers. So once this new radar comes in place and all the modems, the FTI lines, I'm going to be able to support 56 customers. I'm not only providing the feed for air traffic control, but I'm also providing a feed to national defense, to the military, and immigration. I can't remember their department, but we send a feed to them. And it's not A lot of people say, well, you send the feed so they can control illegals. No, we're not controlling illegals. We're controlling vehicles because we don't want any. The main purpose for this system is not to have an aircraft intrusion in the airfield. So do we have immigration and the airports? Absolutely. So I'm just doing my job, providing that fee, so that way it also looks for animals like birds, fox. The other day they found a dog in the middle of the runway. So it was kind of cool how to see that presentation on it. And I also compared it to our NEXRAD because the NEXRAD system is a weather system and has evolved. Before it used to tell you the velocity of how the clouds is coming in, how much rain is going to be. And now with the new system automation, it gives you the dimension of that raindrop, which I would have never thought that would happen. Something that I do is going to provide a dimension of a little raindrop and the impact that it does to air traffic, because we know that if we have a lot of rain, we have to space out the landing or the departure and landing of the aircraft. And of course, you can affect people. I also look at the big impact on my job. If I don't do this, how is going to delay somebody to go home or go to work or do whatever they need to do? So that's why I take a lot of pride in my job. So I like to educate myself.
We can see that. I love that. You mentioned different systems, agencies. There's a tendency to use a lot of acronyms. So for those that aren't familiar with what STARS is, what ASDE-X is, and I can't remember the other one you mentioned.
NEXRAD is a National Weather Radar.
Mm-hmm.
And that's the one everybody's familiar with because they announce it in the news. The next generation radar provide you this. That's what the NEXRAD is.
Okay.
The ASDE is the system display equipment, and that is within the airport that allows the aircraft to land and direct them within the air traffic of the airport itself. And that gives them the capability of directing that aircraft that landed to their gate and the route.
And then the STARS?
STARS is a system, is our system display. All your analog system comes in here, and that's the displays air traffic uses to see the aircraft.
Very good. And I think you mentioned one more. I can't quite remember, but it was one of the three you mentioned you work with.
SR9.
Yeah. So you can talk about that one too.
Air surveillance radar.
Mm.
So, and that's the free air traffic uses to control the air up to 60 nautical miles. Because once it goes from the ASDE, after you 20 nautical miles, it's like, okay, I don't care for you. The feed goes into the ASR9. The ASR9 picks it up until 60 nautical miles. Then you have the secondary radar, which picks it up all the way up to the advertised 200 nautical miles, but it actually goes up to 300 nautical miles.
Well, so all different systems under everything radar that are just talking to each other and collecting different pieces of information in order to display, say, to air traffic. Sounds like that would be very cool. Can you tell us about how it is that you landed on this career path and what kind of skills you need to be qualified?
When I first joined the military, I knew I wanted to work with aircraft. I had the opportunity to pick my career when I went to the military. So it was either ground radar or air radar, because I scored really high in my mechanical and electronical, but I scored horrible on my English. Of course, English was not my first language at the time because I just came from Mexico. And of course, in high school, they teach you ELD, so I hang out with all my Mexican friends. So I didn't have the need to learn English right away. I had the worst accent when I went into the military. And the only thing I remember telling my recruiter is I want to work with aircraft. When I went to TED school at Keesler Air Force Base, they gave me the opportunity to see both ends of the scope. The air radar is you fly with this aircraft and fix the transponder on the spot, because that's the way of communicating from the plane with air traffic through via transponder to the radar, and it goes to the air traffic, right? So I like heights. I like climbing my radar. I like having my harness, but I don't like flying. Being up in the air and fixing equipment was a bit scary for my little comfort. So I had the opportunity to go to ground radar, and what is fascinating about this is that I'm in the middle of the airport, in the middle of the runways, fixing my systems, and I get to see all these aircrafts land and take off. I love the Angels, the aircrafts. I had the opportunity to see them, the F-16s, and that's what sold me into radar. It was not an easy career. I did cry myself when I went to tech school because I'm like, what is this? Capacitor and resistor, I need to learn all these math. Math, I was pretty strong, but I'm like, velocity, power, reflections, RF, what did I get myself into? I cry myself every day before I went to bed because I was like, I can't fail. Because everybody was like, if you fail out of radar, you're going to go and be a chauffeur. I'm like, I have this unique job that I can't do. Use my skills, do maintenance, just to be a bus driver. So everybody made fun of me in tech school because I would walk around with my Spanish English dictionary and everybody would make fun of me. They're like, wow, there he goes. You need your little book to respond. It was scary because I felt intimidated by a computer. So taking apart the computer, we were able to fix components level at that point. So a capacitor, resistor, a diode, it was soldering, desoldering, make sure you don't screw it up because you're going to fry the board. And now you're dead in the water. If you don't solder this little resistor the right way, now instead of spending $5 at a time, now you're spending $1,000 because you fried the board. It was very scary, and at the same time, it was fun. So that's how I ended up in radar. So slowly, I started learning what radar was. But of course, everything has a basic principles theory, and that was the hardest part. The system itself is awesome because you can measure results of your work. But when you have to deal with theory, you're like, really? What do I want to know this? But after 25 years, now it makes sense why they're making us read the theory. So that's how I ended up in radar.
Very interesting. As you were talking and mentioning the heights, I got a visual of you climbing to fix some equipment. It sounds like a lot of your equipment is at a certain altitude. When you mentioned walking around with your Spanish English dictionary, that speaks volumes to recognizing what you need to conquer the obstacles that are in your way, despite what other people might think about it, despite them potentially critiquing you or even bullying you playfully. Sometimes you have to have that awareness where your shortfalls are and ask yourself, how am I going to compensate? If you just know you have shortfalls, but don't do anything about them, you're not going to get very far. It's that intention of, this is not going to stop me. I have to carry around this Spanish English dictionary. Duélale o a quien le duele. I'm going to make it happen. It's that attitude to make ends meet no matter what. That's commendable. Moving on to our next question. What advice do you have for those that may be interested in a career involving radar technology?
The advice I got is whether I concentrate more on female side, right? Because my career is mainly dominated by males. So working with a girl, they always have a hard time. Perfect example, when I transferred I was an awesome staff sergeant, tech sergeant in the military. I was training all my little airmen, right? I call them little airmen because they were airmen. When I went to the FAA, some people were intimidated because I was a female. They're like, great, they hire a female. She doesn't know what she's doing. We're going to have to cover for her. I'm like, no, you don't. I know how to pull my weight. I had to do my physical to be able to carry 75 pounds before I got hired into the agency because that's how heavy some of our motors are. And other stuff are even more heavy. You need two people, the two-person rule. But I would tell, if anyone is interested in radar, don't give up. Don't listen to what people say. You know your own goals. Like, people are going to say, you're just a girl. You're not going to be able to do this. No, prove them wrong. And that's what has helped me in my career. That's what I like to read my TIs. I asked a lot of questions. I have proven so many people wrong that just because I'm a female doesn't mean I don't know what radar is. Doesn't mean that I'm afraid to work with RF or frequency, high frequency or high voltages. Just learn. Don't give up, because a lot of people like I said, a lot of people will try to push away just because you're a female. No, you're a female. As hard as it is being a female in a man's dominated world. So, and I see how they stereotype females in this career, because I knew a couple of females too that I used to work with. Well, I'm a girl. I'm not going to climb. So you climb for me, or I'm not going to lift that. No, if you're going to do the walk, do the talk, or vice versa, however you guys say it. But be able to prove that you like to do is awesome, because once you break the, for me, once I broke that barrier of my English, Spanish difficulties, the sky was the limit. And formula is going to be the same in Spanish, it's the same in English, it's going to be the same in any kind of language that you want. Electricity is the same across the board. So mechanical is the same across the board. Yes, of course, some have more calibration than other ones, but don't let anybody tell you just because you're a female and this is a nominated male position, put you down. And now I have the majority of my coworkers, they respect me more than they respect my supervisor in some places. And I'm like, because I like to put my money where my mouth is. So if I'm gonna say I know how to do this, it's because I really know how to do it. And don't be afraid to say I don't know, because you don't know what you don't know. So you always have to that guidance, and use your network. Your friends from school, your friends from high school, ask them questions too, because that's what has saved me in the agency. Even with the collision, I have met a bunch of friends that they concentrate in radar. So I know when I have something, I network through them and they help me overcome my obstacles. And that's the beauty of this system, right? Our systems are technology. And my biggest thing is the sky is the limit. Just keep studying, don't give up. People are going to bully you. People are going to tell you, you're just a little radar tech. Well, I am a little radar tech, but when my system is not working, even the governor's calling me to see what the status of my equipment is.
Wow.
I'm a little radar tech.
I love that. And I think everything you just said speaks to the resilience that we carry with us and our ability to change the narrative when someone doubts us, or when someone culturally carries these perceptions that women can't do certain things, or that's what we've all heard, right? So we might not necessarily question it unless we're in a field like this. So it's not a reflection on us, it's a reflection of the things that we perhaps need to unlearn from our culture. We have amazing things within Hispanic communities, but there are some things that we need to unlearn in order to push us to these new heights. So for our next question, you mentioned the Hispanic Coalition and some benefits you've already gotten from being a part of this organization. We know the Hispanic Coalition is an incredible resource for its members in many ways. And yes, you hinted at this, but how has the NHCFAE supported your journey as a technical profession?
Personally, I like the collision because whenever I need something, I can always get guidance, right? The biggest thing is guidance. When I'm struggling with something, they help me or they advise me, and I can talk to you, I can talk to Hilda, I can talk to somebody in California that is in a collision. I'm a tech, so that's all I know how to talk, right? So the other day, it was coincidental because I talked to one of my friends, Ugo, and he's in LA. And we were talking about, we live in a big world, but at the same time, it's so small because out of the blue, he's like, you should join the collision. I'm already in the collision. It was funny because I didn't know. I was like, yeah, I don't advertise it because I am so busy. I don't get into social media a lot anymore because I'm really busy. And what I do like about the collision, and I wish people would take more advantage of it, is the scholarships that it offers people that want to drive and try for the next level. Because I'm a big believer in education. Education will get you whatever you want. So I did struggle for a while, but I did finish my PhD, thank God. And that's why I always tell I like the volunteer stuff that they do at the schools. And I like to advocate the scholarships. I didn't use it because I was going for my PhD. So, and I tell people, take advantage of it. Don't let money be a stopper. And start at the community college. That's where I started. Start with the class, started with 2 classes, whatever you can afford. Get scholarships. You have the Coalition offers an awesome scholarship. And you have other little scholarships that support Hispanic as well. I concentrate more on Hispanics because that's my culture. And I do help other people too. Even my coworkers at work, we're not Hispanic. Who cares? I'm not Black and I want to join you. I'm not white, but I want to join your coalition too. I'm an American. No matter what color your skin is, we all bleed red.
Yeah.
And that's what I like about the coalition. To me, the coalition is a big advocate of education for our younger generations.
Yeah, we absolutely want to continue changing the narrative and updating our definition of what it means to succeed, what it means to be purposeful in our community, what it means to have careers that impact everyone around us. So, Patricia, thank you for sharing your expertise and the work you do to ensure safety and innovation in aviation. For our listeners, if you enjoyed this episode and would like to connect with more aviation professionals like Patricia, please consider joining the NHCFAE. Membership gives you access to mentorship with aviation professionals from all walks of life, scholarships like Patricia mentioned to help you meet your education goals, and networking events to take these kind of conversations and, of course, your career even further. So thank you to everyone for tuning into this episode of the NHCFAE Career Series podcast. If you enjoyed hearing about Patricia's journey and the world of radar technology, make sure to follow and subscribe for more episodes about aviation, the aerospace industry, and professional development. I think your dog agrees with us. Visit the NACFA.org to learn more about our mission, our programs, and membership opportunities. So see you next time.